going to talk today about Kubernetes and Docker. Take a look. Hello. In this Kubernetes presentation, I'll be covering the basics of Kubernetes, as well as containers, and more specifically Docker containers, and the advantage to them over traditional bare metal and virtual machines. I'm also going to show you a quick way to get set up on your OS X computer to both run Kubernetes as Minikube and Docker images. But first, let me tell you a little bit about myself. I've got 20 years of experience in the field as a developer, a system administrator, and an architect of entire systems. I've been on both sides of the DevOps wall before and after that wall was bridged. Even when developing, I've always programmed to the systems and the services that would be available to my applications, as I've always believed that it's very important to have a full picture and develop towards that full picture of the system as a whole. I'm currently working at Pythian after they acquired a company I started just over a decade ago. I currently hold the role of lead architect at Pythian in the DevOps division. I love trying to find new ways of tackling old and new problems, but will revert back to tried and true battle-tested ways whenever that's deemed necessary. As we all can relate to that, if we know that something's going to work and we need to get it done, sometimes we go back to those ways. A little bit more I want to go over about me, other than often being mistaken for Conor McGregor on a regular basis. Professionally, as a consultant, working for and owning my own consulting company, I've gotten a lot of opportunities to work on a lot of rather large projects. I've worked for some of the most well-known brands in the world, including Activision on the Call of Duty series. Apple did their FileMaker releases for them. eBay, PayPal, actually wrote the PayPal certification program for them and PayPal PHP SDK. Live Nation from the ground up, both the back end and front end of it, as well as doing the infrastructure. As recently, Verizon, which was another container, which was Messio and DCOS stack there. Starbucks, worked at teached at NASA Ames Research Center for a little while. Did some work for Shutterfly, Namecheap, Career Builder, also Ustream TV. Back in the day when Facebook was going from EDU to everything big we know today, I did some work on Facebook as well when they were having problems with their APC cache. The RealReal.com signatures network, which consisted of U2, Kiss Online, Kiss Army, and about 200 other music fan sites like Britney Spears and so on. The list goes on and on, reaching as far back as Friendster. Also, back in my PHP days, I used to speak about performance and scalability while I was working for Zen, the PHP company. I also started a few books with Sam's Publishing and grew a few user groups with which I had and held monthly meetings in the San Francisco and San Jose Bay Area for those groups. Those were PHP user groups. Let's see here. So Kubernetes. Let's get a little bit about its history and its origin, so we can kind of get an idea of why this one's kind of taking the prize and leading the way as far as the number of installations. It was originally developed by Google. They used 15 years of R&D developing this. It was developed and designed and heavily influenced by the Google's Borg system. Even some of the Borg system team members came over to work on it as well. Originally, the code name for the project was Project 7, which is a Star Trek reference to a friendlier Borg. The 7 spokes on the wheel are a tribute to that project code name as well. That's why you see the 7 spokes on the logo. They went public with a Apache Commons license release of this, an open source release of this, July 21st, 2015. At that time, Google partnered with the Linux Foundation to form the Cloud Native Computing Foundation, which is where we see it now. You also see in this presentation and quite a few other places the abbreviation for Kubernetes as k8s. So you'll see k8s all over the place, and that's going to be just a lot easier for everybody to type, and something you need to know to look for when people are talking about Kubernetes. Another little tidbit: Kubernetes is the Greek for a helmsman or a pilot. Moving on to a little bit about the architecture of it. So here, next slide. So, what does Kubernetes exactly do? So, Kubernetes provides us a platform for automating deployment, scaling, and the operations of application containers across a cluster of hosts. So, and it supports a large range of cluster tools, such as Docker, which is the one that we're going to focus on mainly today, but there's a lot of other container tools that it does support. Obviously, since Kubernetes was started by Google, Google had let me contain that for you. There's LXC, RKT, which is part of where it was developed by CoreOS. It's part of it as well. And here's some of the features that go along with Kubernetes. So there's the automatic bin packing. So what this does is this automatically places like the containers based on their resource requirements and other constraints. So while it doesn't sacrifice the availability, so it's tries to do a best effort to figure out the workloads and to get the most utilization out of each portion that Kubernetes goes on. So Kubernetes goes into workers, which go into pods, and those are management pods, and those workers, it tries to get the most out of each one of those for your containers. So it looks up with this bin packing and tries to find the best spaces. There's self-healing. So self-healing, this will restart any container that fails. So you can define your own health checks. If a container is failing one of those health checks, then it will automatically reschedule that container. If a node dies, it'll reschedule it through the scheduler, and it'll add that container back in where it sees it best loaded and fitting. It has horizontal scaling, so you can scale your application simply up or down with a simple command. So we can tell it to have the number of replicas go up or down. Service discovery and load balancing. So we have load balancing, so it gives the containers their own IP addresses. And when it does that, and it also gives them an internal DNS name for a set of containers, and then it load balances across those containers. It also allows for automated rollouts and rollbacks. So this will allow you to, if something is not going well in a deployment and your health checks are failing, it will automatically be able to roll back. And you can progressively roll out changes to your application as well. So as you make changes, you can push out or roll out those changes across all the nodes that are affected by that image being changed. So it's pretty useful in maintaining state across all your nodes. And we all know that maintaining a constant state is, or desired constant state, is something that's very important and something that gets tricky with certain things, such as Terraform can get things out of state. There's the old school way of actually just editing things on the fly obviously gets out of states, and managing large virtual machine images can be hard to maintain exactly what version numbers are rolled out, so you can get out of state there as well. So this helps take care of that as well. Secret and configuration management. So you can deploy and update secrets to your application without revealing those and without rebuilding your images. So it allows you to maintain security in that way. Storage orchestration. So you have a choice of whether to use your local storage, or you can use a public cloud provider. Google Cloud Computing, AWS, or you can use some type of network storage system. There are extensions and plugins for like Gluster, FS, I think Ceph as well, of course NFS. And there's batch executions is another feature in Kubernetes as well, which allows you to manage your batch and your CI workloads. And it'll replace containers that failed if you desire on those batch workloads as well. And let's take a look at what we kind of need to go through before we dive in any further into Kubernetes. So just a little bit of like what we need to understand before getting into Kubernetes. We got to understand some of the underlying pieces that help, that are needed in order to make this a whole piece. And right now, the main thing you keep hearing me talk about, or that I talked about in the beginning until we were going to talk about, is Docker. I'm going to talk about containers here for a second as opposed to virtual machines, just so you can kind of get some of the differences. I'm currently have been working for a lot of clients that are still using virtual machines and virtual machine instances. This is cumbersome to manage sometimes when doing large deployments because the VMs take a long time to spin up. And whereas the container is a little more lightweight, so we're isolated to, just a set of package and libraries or the application, and it's completely independent from its surrounding or its host OS as well. Where the virtual machine has to communicate via a hypervisor on the same physical shared hardware. And a hypervisor, if you're not familiar, is a virtual machine monitor. It's computer software. It can be firmware or hardware that runs a virtual machine. A computer which is on a hypervisor that runs one or more virtual machines is called a host machine. And each virtual machine is called a guest machine. So you'll have your main host machine that's lying underneath the layer, which I'll show here in a diagram here in a minute. And then above that layer, you'll have your guest machines. And building those guest machines, that's like if you're at Amazon and you want to spin up an EC2 instance. There's already a host machine that Amazon has, and you're spinning up your instance type as a guest instance on top of a hypervisor, and that's being spun up on top of that. So, and you have to spin up an entire stack on top of that, the entire OS, and this all takes some time. You can, of course, create AMI images and try to speed these things up, but that becomes a lot more difficult to manage when using configuration management software as well. So let's go into a little bit about what the differences are. And I'm going to show you the diagram here of what the differences are in the Docker containers at a glance here too. So let's see here. So virtual machines versus Docker containers at a glance. So this is like I was saying, this is kind of like what I was talking about with the EC2 instances, where this is Google Compute instances too. Whenever you spin up a compute instance, the VM requires the whole guest OS and any supporting libraries to be installed on each instance. This is also true if you have your own bare metal machines and you're running virtual machines on top of these as well. The Docker containers, however, are host OS independent, and can make better use of the shared resources being more cost effective. Meaning that generally with virtual machines you scale up larger than needed, and that's your way of being HA and highly available. And then for containers, you can spin up really, really fast, so you can set your thresholds for spinning up new containers, or like we see over here in the bottom right, I've got your bin libraries with application 1, which is represented as A1. To get another A1 out, the uptime on that is going to be really, really quick. In most cases, say if it was something small, just like a web server or something along those lines, you're probably only looking at less than a minute, 15 seconds maybe even. Whereas if we had to spin that all up inside, if we had to spin all that up inside a virtual machine, we'd have to wait for the virtual machine itself to build and deploy. And then more than likely you'll have a base image that you would deploy, or base set that you would deploy. And then after that, you would then start configuring and building with, say, something like Chef or Puppet, anything that goes on top of that. So you're looking at anywhere along the lines of 7 to 20 minutes. I've seen as much as 20 on some larger instances where Python's required and some external Java libraries required, a lot of external dependencies. All that can be sped up though by bringing it in. But like I said, you are completely isolated when you're using a Docker container, so you can make better use of those spaces on the machines that you're provisioning. Let's know a little bit about the virtual machines themselves, because you can't get a lot of the same things out of the virtual machines. So this is, I'm talking about a little bit about IA again here, which is with our Chef, Puppet, Salt, and Ansible. So the known behavior of virtual machines. So virtual machines over the years have become very easy to create and ensure proper registration and configuration management and monitoring, meaning that it's pretty easy now to spin up with Chef, do a build and know my current configuration state of all of my machines across anything that Chef server's running, or say if I'm in AWS and I'm using OpsWorks, I would know exactly what all my OpsWorks stacks are running and which ones those are on. To get there, it's relatively easy. You can also get high availability, which Kubernetes allows, and failovers. Since I started talking so much about AWS, I'll stick with AWS. With AWS, you can do EC2 ELBs for internal and external load balancing. And you also would do multi-zone, so you put virtual machines, just like you would end up putting clusters in multiple zones, but or containers in multiple zones. You would put your virtual machines in multiple zones as well, and you could have HA while having the load balancer fail over to one or the other zone if the zone outage were to happen. Also, disaster recovery is something that's thought of a lot and maintained a lot whenever I use infrastructure automation. So HADR is very important, and something that gets us to our client SLAs, or service license agreements, where we're saying 999s or 59s, and these can be very important, and these can be the difference between losing thousands of dollars as opposed to millions of dollars a year too for some companies as well. So there's a lot of the same features. The auto healing, AWS offers this at the EC2 level as well as an OpsWorks level for auto healing and images. So knowing that an image state, there's a specific listener in AWS that if it fails a health check, it then will recreate. That's in OpsWorks, and EC2, if it starts failing as well, it can auto heal as well there as well. Those are all simple check marks or CLI additional calls you make in order to set those. These are a lot simpler actually to set in Kubernetes, even though these are simple check marks in AWS. Um, uh, and then in addition to the infrastructure architecture for a VM being very close in this and similar, and being able to have all these great tools out there to maintain, monitor, and manage it, just like we would be able to do with Kubernetes and Docker. You're also very confident in the fact that it's going to behave the way that you have planned it for. Um, it's not sharing resources with anything else, so you might have oversized it a little bit, or have it hitting a certain percentage before it auto scales to another machine. Um, Always keeping a little bit of overhead, but you knowing that it's not sharing any disk I/O or any memory with other um, processes and containers, will know exactly how that's going to react. And I'll get into why that's been a problem in the past here for me. I've actually had some container issues in the past where this knowing would have been better, where Messios actually went in, and Messios Marathon running DCOS was having problems with cluster and uh, MySQL cluster, and that MySQL cluster wanted file pointers, but Messios didn't allocate it properly when it was allocating the containers out, and GlusterFS was taking all of the file pointers on the system and very heavy load times. Anyway, but there are some drawbacks for having VMs as well. They are bare metal and cloud drawbacks. Like I said, they're typically over allocated. They take a long time to build and deploy, and they're expensive to maintain and run. Meaning expensive to maintain and run, meaning that it takes somebody quite a while to write all of the infrastructure automation and Chef or Puppet. A lot of it's out there, and like Chef has its own supermarket. There's tons of Puppet out there, as well as Ansible code out there. But you still have to write for your own environments as well. So this has to be maintained. These files and the resources that you have to write, or libraries you have to write, tend to be, from what I've seen, a little bit bigger and a little bit more time consuming than what I've seen to get the same results to bring up, say, something like an HA proxy on just a simple machine that has a specific configuration. So we'll kind of touch on that here in a little bit, but the way of going about doing that is definitely with a VM and bare metal, using IA infrastructure automation is a little bit rougher. Let's see here. Next. So I wanted to talk about this because containers, they're not new at all. I was actually using containers in 1999, 2001, somewhere in there, with FreeBSD jail. I also used Zen in 2003 at u2.com. We set up development environments, all independent of one another, but was able to do bleeding edge development as sandboxes in a virtual environment for everybody that way. So this thought of virtual machines and containers, Zen's more of a virtual machine and jails are more containers, has been around, and this process isolation, basically this process isolation has been around for quite some time. However, it was a little bit against the grain back then. It was thought that you wrote you figured out what your traffic load was going to be, and you sized your machines based off of best guesses, and you hoped that you oversized, and you were efficient enough with your application writing and that was the way that you did things back in the early 2000s. Um, so it was a little bit against the way of thinking, and as well it was very cumbersome and clunky. So, that was part of the challenge. So in the challenge section here, like the hardware wasn't fully at scale like we have now. Couldn't have, you know, 10 to 100 different containers running on the same host machine. A host machine might run 10. I never ran a host machine in production ever at that point in time. They were all for development, so I didn't see a lot of production level wide adaptation at that point in time, but that was nearly 20 years ago, which was a little bit before Google started their development on Kubernetes. Like I said, it was very clumsy, so the maintainability and repeatability across large scale and infrastructure was neither easy or widely tested. Back in those days, of course, most of our configuration management was done with shell scripts, which can be just as properly maintained as something like Chef or Ansible if you're meticulous enough. But it was different from place to place as you went from one place to the next. And just maintaining that and repeating that was a nightmare, and not something that I actually seen done. So now we have this. There was a huge push around 2011 to 2014 for DevOps. We've all seen the DevOps explosion in growth. So there's been rapid development around all these tools. So like Docker Swarm, Kubernetes, SEO's Marathon, Cloud Foundry, and some others. Those are more of the container-based, or the orchestration for containers. But that's that at that point in time, people started seeing the need with these large VMs and the underutilization of these machines, and prices per month just being blown out of the water month to month, because even though you can have auto scaling with VMs, they still are a little bit oversized, as I mentioned earlier. So the hardware had matured greatly. And at this point in time, also had been battle tested, because Google had went to the mats for everybody and spent well over 15 years testing and trying to perfect their own with the Borg and Kubernetes projects. So this is how we ended up with what we have today. So now the next question I want to answer is, so this is why containers now. Next question I want to answer is why Docker? There's plenty of choices out there. Why is it so much more popular than all the rest of the choices? And you'll see my little lucky clover down there in the right corner. I think it was a lot of the luck of the draw. It says it wasn't even close to one of the first containers. It wasn't released until 2013. One thing they did do right, it was open source from the start, but however, had that been 10 years before or even 6 years before, the adaptation of open source in all companies and the use of it wasn't always the way of thinking, so it would have been way against the grain and something that somebody would have really had to gone to bat for. This was something that was going away around this time, which was the right place, right time, for the DevOps engineers and architects who were looking for leaner, faster ways than spinning up a full stack of VMs, which just by design is slow to start. We would actually spin up VMs based on time, knowing that our load would hit at a certain time of the day at certain clients, and we would have machines sitting there just waiting just in case, and sometimes it never happens. So this is things that can be avoided. So this was ease of use. By the way, was another during the DevOps revolution, like I'm talking about here, that those years, like the 2011 to 2014 years, I started seeing developers really adopt this. I seen developers using it more than I saw the sysadmins and DevOps engineers. The DevOps engineers were in the trenches on one of the cloud networks or on their bare metal machines, trying to get their own VMs running, and were completely focused on infrastructure automation at the time. So this wasn't this was yet another thing to learn, and a DevOps is a field in which something you learn never stops. So there's a ton of new things being thrown at everybody. So the fact that the engineers had picked up on this one and found it easy enough for them to use really helped them out as well with the adaptation of it, or the adoption of it. Sorry. So that being said, why are we going to use Docker? You know, what does Docker even provide for us? So, well, by the way, I wanted to, well, I'll wait to the end on that, but I wanted to point out that you can still use your Chef and Puppet with Docker, but I'll explain that here in a minute. So the configuration's simplified. Docker files in combination with composed YAML files make it very easy on the configuration. Developer productivity is easily configured tools. Like there's like the k8sCrush I just saw, which is a great tool for easily spinning these up. All visually, it's a GUI, which will allow developers to stand things up and test it very quickly in their own local sandboxes. So I've seen the use of this. I've seen the use of Vagrant in a lot of places as well to get the same effect. So using Vagrant to spin up, and use Vagrant to run your infrastructure automation for Chef or Ansible or what I have, or Puppet, and people using Vagrant to do their local development. But you can also use Docker to do this as well. And I've seen a lot of developers, just determine what technologies they wanted to use and run with it. You have application isolation. So you have isolation from the application one another and from the underlying infrastructure itself. Rapid development. So there's nothing installed on deployment. They're just the binary images that are put on, and the processes are kicked off. So it's very, very fast. And this is what I was talking about with the infrastructure automation, the build management. So with simple configuration, build images are easy to create. You can pull and push image layers. So from wherever you're at, you can go on after you've pushed an image to a container. You could actually go on the container, install a few things, and push the image back, or create a new image name. You can kind of think of these as disk snapshots that you're creating. So, and then for what I was talking about as well, it'll do image hierarchy of the instances from using the from command in the Docker build. This makes it really nice. I kind of think about it as I've done a lot of infrastructure automation, so I think of it in a Chef term. I'll put it in another term here as well, but Chef would use roles, and with roles you could stack on like a base server role, a web server role on top of base, so base always got executed. So you can do the same thing here, so you can always say image hierarchy from base and then add the next one on, right? This is any hierarchy type system would have something similar to this, but this is a way of building those snapshots one on top of another. I'll actually show later where there's a cache that goes along with that, with the image hierarchy. So only diffs will actually get pulled on those, so which makes it even faster on deployments. So let's see here. So I'm going to get a little overview of Docker with the a diagram here that I put together. So, this Docker overview is showing 3 containers, which is your sandbox, which is your isolated process or processes, but it's your isolated process with its own namespace, and it is running from a client has either ran it from the daemon that runs on a Docker host and told it to execute these, which this is something that Kubernetes will take care of, and as well as the registry that you see off to the right hand side, off to the far side. The registry is a container image store which houses your different quote-unquote snapshots of image states, which like I was saying, you could layer these. You can have a scratch image, and then you could layer the next one is your SSH, and then your next one is your application 1, and so on. And that would all get pulled and pushed and pulled over into your image cache. And then your image cache would then check to see if there's any differences in order to push or pull them again, so it would run diffs against those before making sure that the state of the containers were at that state. So the containers are ephemeral, and meaning that any time the life cycle of a container goes away, any data that was in that container goes away as well. So storage volumes are needed in order to keep anything you want to keep persistent. I found that you can do this, even with S3 buckets in AWS, but any storage volumes with Kubernetes, like I said, we can attach GlusterFS, NFS, and a few others, and also with the registry, Amazon. I haven't used to prove this yet, but I believe you can, as I created an endpoint for it. Amazon has an EC2 Docker image registry you can use as well to pull and push and maintain your registry in AWS. So a little bit over, so that's a little bit of the Docker interview. So let's go back now and talk a little bit about Kubernetes and do a little overview of it as well. Excuse me. So Kubernetes is an orchestration tool for desired state management. So what I've got here a diagram of is we've got our deployment YAML, or an app1 YAML, which contains our deployment, which has pod 1 in it and pod 2 in it. And pod 1 contains 2 images, and it needs 3 replicas, whereas pod 2 contains image number 3 and has 2 replicas. This YAML file will communicate with the API piece that you see in the k8s cluster services, which is the Kubernetes cluster service. And then it'll communicate, make time with the scheduler then to put it over into the workers. And that K in the workers is the kubelet that runs on each one of the workers. So as you saw on pod 1, I had 3 replicas. So you see it gets distributed evenly. There's above each worker, you'll see a P1R1, P1R2, P1R3. And then the same for pod 2, it just got distributed a little bit different. P2R1, P2R2. And if we lost something, say like if we lost worker 2, P1R2 would then go back to the scheduler because it wouldn't be able to communicate with the kubelet anymore. And the scheduler would then say, okay, where do I have the best amount of space? Do I have the best amount of space so I can put this someplace? And it would pick, say, if worker 1 was less loaded than worker 3, or better suited, it would put P1R2 on worker 1 if that went away. I hope that's making sense. So anyway, that's how the failover and the faults go when talking about these workers. And the scheduler as well. Sorry, and the scheduler is what tells who goes where and when things get pushed out. So and if assures quality of service. Let's see here. Let's go into this piece here. So from this, I got a pretty good understanding of Kubernetes and how Kubernetes is working and the worker classes, and then how Docker then fits inside of it. So then I wanted to see, and I want to show you all how then you can go ahead and test this out on your own. So running on OS X, and you can do this on Windows. I'll provide a link at the end here. It's actually the same link. If you go to the Kubernetes website and look up downloads for Minikube, it'll show you how to do it. This happens to be a list of the requirements for OS X. So in OS X, I did it using Homebrew, and it just makes things in life a lot easier. So install Homebrew if you don't have it already. You need a hypervisor. So I picked a Docker machine hypervisor here. Some dependencies, not all of these were needed, but I had some other things that I was playing with. But OpenSSL and OpenSSH are needed. libSSH I believe is needed as well. I don't know if libSSH2 is needed though. Docker, only the Docker Composer, and Docker Machine are needed. k8sCrush is not. However, it does provide for some nice tools. And then Kubernetes, the Minikube is what you're actually running locally, which will emulate Kubernetes on your machine. And then they'll have the Kubernetes CLI and kube control. So and those allow us to make the control the cubes and to make our command calls to Kubernetes as well. So like we'll manage Minikube with those. So I went ahead and I put together a script just to make things even easier on you. So there's a script here now that I put together. It's just a simple bash shell script that'll go ahead and it'll do your brew installs for you. And it'll actually expose the deployment Hello Minikube. So we're putting in an image. That image is just the Hello Minikube image, so it's for testing. And it literally runs a counter and just says Hello Minikube. And then you expose that deployment, Hello Minikube, and the node port, which we got on 8080 here. And it takes a few seconds for this to spin up, so I gave a sleep of 5 here. And then after that, you can go to the Minikube dashboard by typing Minikube dashboard. That actually pulls up a Windows, your browser window, and it's got a really nice admin, which is their Kubernetes interface, your GUI interface, in which you can actually see this running. You can even change some of the settings about it in there, but you can also see the web page with inside of it that it's calling and the count number and everything as well. Okay, so once you get once you are able to play with that, one of the things you'll have to ask yourself and maybe you want to ask yourself before this, before you even play with it, is why do I want Kubernetes and Docker? Well, one, of its resiliency, its self-healing, horizontal scaling, service discovery, load balancing, automated rollouts and rollbacks, and config management are just done way simpler than anything that I've seen using VMs over the past 10 plus years or more. So it seems to work a lot faster. It's a lot more resilient. The healing happens a lot faster. But like I said, there's probably some things that need to be looked at with resiliency. I had some initial, like I said, initial hang up with Marathon, Mesos, and DCOS, but I'm guessing there's got to be a way that I've missed that is probably in there that allows you to tell which containers play nice with other containers, so that they're not put out on the same host containers or same host um, workers. So I'm sure there's something in there that allows for that, and allows you to tell it where to go. Another reason why we want to do this is operational excellence. I'm constantly going to know the state because it's going to constantly keep the current state. Anything that's not in the proper state, it will take out and it'll auto heal that state. It's highly available, so it'll auto scale up for you as needed. And it's the smallest fingerprint of the infrastructure possible out of the bare metal VMs that we've given in this practice exercise here. So it's literally going to, the implications of that is it's going to improve your SLAs. So it's going to improve your SLAs with your clients, if you have clients that you're servicing, or yourself if you yourself are the client, which could save you tons of money, or possibly if your SLAs are more, if you're running a SaaS service, you can start charging your clients more. Your customer experience is going to go up whenever you got that high degree of maintainability and repeatability and consistency. Customers are going to know what they get when they come to your site or to your web application. And then we're also going to have enhanced productivity. So, the enhanced productivity being that the fact that the users know, the developers know how to use these tools. Like I said, they've been using them for some time. That and the fact that it's easy to get these tools out to the developers and get these sandboxes built for the developers so they can test things out. They can be on the current versions of the images or on bleeding edge. And the maintainability. So maintainability has a lot of meanings when you're talking about operational excellence. There's a large job pool here. Matter of fact, the job pool for Kubernetes is way larger than any of the other job pools out there for orchestration of containers. So if you're looking for some more job stability, this is definitely worth learning. I think there was a report that went out. There are over 20,000 K8s professionals and it's growing. I mean, it's growing fast and fast and fast, and the interest of it is growing, 8 times more than the next closest, which I believe the next closest is Docker Swarm and Apache Docker Swarm, sorry, and Cloud Foundry is actually pretty close to it as well. But it's also got the largest adaptation and community support, so the largest open support community as well around it, open source community. So that's it for why, and why I hope you've enjoyed the presentation here and learned a little bit about Kubernetes and Docker and the container, and how it can benefit you as far as using it against something along the lines of your VMs currently. Like currently, a lot of the clients I'm using are working towards right now are all using full image or using EC2 images, where this could be a smaller footprint and possibly some easier healing with using Kubernetes and Docker. So, yeah. And then I did my notes taking here the old school way for this presentation over the last 2 nights, late nights after working 2 jobs each day. Had a little stage set up. I was going to do a video to go along with this, but it's getting late in the day on Friday, so I doubt that's going to hit it over there. And any questions and comments, you can contact me at rock@devopsfied.com, and there is my phone number there at the bottom, 408-679-8604. I look forward to hearing from you. I'd also look forward to doing more of these. I would like to do a series. I've found some rather interesting larger scopes of this that I'd like to go down for Kubernetes and with regards to AWS, and setting up some cross-regional items as well. So anyway, let me know if you have any questions on this and if you would like to see more.